Hi everybody, my name is Alex Palesandro, and today I will present you some few concepts about virtual networking in KVM and libvirt. So this is always part of the Laboratory 1 of Cloud Computing course. As the first step, I started my VMs, so the VMs for the lab, which are client VM and KVM. Fine, so you can get them ready and they can be used easily here. I configured Virtual Machine Manager as I showed in the last video, so you can go there if you have doubts about the configuration here. And I logged inside this host using SSH. It's pretty easy. You can do that like that. I also showed how to configure. Sorry, typed the wrong password. I also show how to configure a key, SSH key, which is more secure and which has some important advantages. I suggest you to go to the previous video to see that. Okay, so let's talk about networking. We will start by exploring Virtual Machine Manager, which is a graphical interface. It's really nice to use. So we simply have to go to detail, and in detail we have several tabs, and one of them is virtual network. So the first thing that we see is that we have default networking. So the default networking is always there. It's, I think, created at install time. I think it's not started by default, but you can easily start here by just clicking on auto start and then activate by playing here this button, and it's okay. So the idea of default networking is to provide a simple but secure way to start VMs, give them access to the internet, but not exposing them. So this is the reason why they use the forwarding configuration via NATing. So this means that the VM is not an address which is accessible from the outside, but it's only configured, so its access is only done via IP masquerading. And so using the ports to the IP of the hypervisor to NATing the IP of the VM inside. Okay, another important point is that we can set up in this network the network, the range of IPs, and the DHCP configuration. The DHCP is provided by a tool called DNSMask, which you have to install, and you are done. libvirt is able to configure it by itself, and it's pretty easy, and it does not require extra configuration. So here you have an XML description, but before digging into it, I would mention also the other way that you have to explore the network configuration, and this is by using virsh command. So virsh command is the CLI tool that is built by the libvirt project to connect and get information and update information and so on with the libvirt daemon. So it's something that is quite rich, and it's really useful if you have to script your configuration. So if you want to, for example, build script around the libvirt. So the graphical interface, it's really useful when you have to explore and to configure manually what you are doing, but what you want to obtain. But if you have to script CLI, it's always better. So we can observe that you can have here the same network. So it requires an important. So we can dump the same configuration. We can list our networks. I think it's net list. Yes, we have only one, and we also can have this interactive terminal when you only can type all the commands of virt. It's I think easier if you want to explore the internals of version, really understand which are all the possible comments. But yeah, normally you use it as we did in the first case. Okay, then I think it's time to understand a bit about the libvirt configuration. So we have a name, okay, default, fine. We have a new ID, which is generated by the daemon, fine. We have a forwarding mode, as I mentioned, NAT, and you can configure which port will be used to do the NATing. Then you have a bridge. So all VMs are attached to a bridge, which has this name. I can show you the bridge. You can show it by using the brctl show command. This command is provided by the bridge utils package. It's really nice. We have this bridge virb0, which is an interface which is virb0 nick, and we can observe if we type ep link that the MAC is exactly what we expect to be. So pretty nice. We also have, and we also require a network configuration. So here it's this one, which is the default one. So we take some private address, and all the VMs that will use this network will be inside this range, and will take the address by asking via DHCP. So as we did in the last video. So it's pretty easy. Okay. So we can also observe that the first IP is taken by the interface of the bridge. Okay, I would try now to create a new network. So we have plenty of options, still the name, but also all the forward modes. There are several. The first two, so routed and open, are different configuration of the same principle. So the idea is that instead of preventing the VM to be accessed from outside, those configurations allow the VM to receive an address from, for example, from an external DHCP, or to configure an IP and then be accessible from the outside. The difference is a different way to protect it via firewall rules. So open, it's really open. Routed has more firewall rules. There are, I think it's not. So it's quite advanced. I will not go inside all the details of this configuration, but the idea is pretty much the same. The configuration that you require to have if you would like to make your VM accessible from the outside. So I think when OpenStack was not there, and you do not have you do not have pods and containers and Kubernetes, when you would like to use and export an internet service using a VM, you will use this approach. So you will create another bridge, connect a physical interface to it, remove the IP address, give the IP address of the hypervisor to the bridge interface, and then set the other interface in manual mode. And yeah, you are pretty much capable of having your VM accessed from outside. It was nice because you can have your I don't know, your web server in a VM, so it was more secure than simply having it on your hypervisor. So I think it was really popular before cloud management system became really adopted. So I would say the beginning of the second decade of the century, so I would say 2010 and so on. But then when OpenStack arrived and projects like OpenStack, you always had those different concepts like floating IPs and so on and so far. And so the way where your VMs were exposed was a bit more more virtualized. I think the internals were hidden and you don't have to deal with those kind of details anymore. But at a certain point in time, it was really, really popular. Then you have isolated. Isolated is some configuration where you have not access to the internet, no ingoing and not outgoing. This is something that is useful inside this lab because at a certain point, I think you have an exercise where you are asked to build some isolated network and use a configured FreeVM to create a routing topology where the traffic goes from the first VM to the third VM through the second one. So it will be useful for you in this lab. And the last one is used for PCI pass-through. So if I want to obtain the best performance I can obtain in a virtualized environment, when I deal with VMs, I have to deal with PCI pass-through. So I'm literally using the real network interface, and there are some hardware support that allows me to use it securely. So I think you covered that in the course. So it's something called like AMD IMMU or Intel VTD. But yeah, it's pretty much that concept. So those are the possibilities. I think we are pretty much done. So I think you are ready to go into this lab. In the text, most of the things that we proposed here are mentioned. All the details you can find here are pretty much already there, and I show some comments which I presented in this video. Yeah, feel free to ask me if something is not clear in comments or contacting me. So this is the topology that you have to create at the end. So I want to mention before, those networks will have to be internal. So no configuration, no internet access inside for these two network. And important point is that all those VMs have to be accessible via SSH. And this is I think the most complex configuration that you have to do here. So it's pretty simple as an exercise, but it's nice because you can also do, and this is required in the last point of the exercise, you can always you can test the performance. And in the next lab, we will do the same with using container, and you will see the difference. You will understand why container start to be a bit more popular in recent years. Thank you very much for your attention, and enjoy your lab, and see you.